8786. Why is it necessary to vent all aircraft fuel tanks? A. To ensure a positive head pressure for a submerged boost pump. B. To exhaust fuel vapors. C. To limit pressure differential between the tank and atmosphere. The correct answer is C. It is necessary to vent all aircraft fuel tanks to limit the pressure differential between the tank and the atmosphere. Fuel tanks are designed to maintain a balance of pressure to ensure proper fuel flow and prevent structural damage. Venting allows the equalization of pressure inside the tank with the surrounding atmospheric pressure. Fuel tanks experience pressure changes due to factors such as temperature variations, altitude changes, fuel consumption, and fuel sloshing. Without proper venting, pressure differentials could build up inside the tank, potentially causing deformation, fuel starvation, or other operational issues. By venting the tanks, excessive pressure differentials are prevented, ensuring the fuel system operates effectively and safely. The option mentioning a positive head pressure for a submerged boost pump is not the primary purpose of venting aircraft fuel tanks. While maintaining a positive head pressure can be advantageous for pump operation, it is typically achieved through other means such as proper fuel system design, pump placement, and fuel supply management. The option referring to exhaust fuel vapors is partially correct, but it is not the sole reason for venting fuel tanks. Venting helps in releasing fuel vapors, which can accumulate and potentially pose safety hazards. However, venting also serves the purpose of limiting pressure differentials, as discussed above. 8787. According to Part 23, what minimum required markings must be placed at or near each appropriate fuel filler cover for reciprocating engine-powered airplanes? A. The word Avgas and the minimum fuel grade. B. The word fuel and usable fuel capacity. C. The word Avgas and the total fuel capacity. The correct answer is A. According to Part 23 regulations for reciprocating engine-powered airplanes, the minimum required markings at or near each appropriate fuel filler cover include the word Avgas and the minimum fuel grade. These markings are essential to indicate the type of fuel required for the aircraft and the minimum grade or specification that must be used. The option stating that the markings should include the word fuel and usable fuel capacity is not accurate. While usable fuel capacity is important information for the pilot, it is not specifically required as a minimum marking according to Part 23 regulations. The option mentioning the word Avgas and the total fuel capacity is also incorrect. While total fuel capacity may be useful information, it is not specifically required as a minimum marking according to Part 23 regulations. 8788. The location of leaks and defects within the internal portions of the fuel system can usually be determined by A. Visual inspection for evidence of wet spots and stains, and feeling for unusually warm components. B. Performing a fuel flow check. C. Observing the pressure gauge and operating the selector valves. The correct answer is C. By monitoring the fuel pressure gauge and manipulating the selector valves, one can effectively identify and isolate a section within the fuel system of a large aircraft that is experiencing an internal leak. 8789. What type of fuel boost pump requires a pressure relief valve? A. Concentric. B. Sliding vane. C. Centrifugal. The correct answer is B. Due to its constant displacement nature, a sliding vane fuel pump necessitates the inclusion of a pressure relief valve in its design. 8790. To prevent vapor lock in fuel lines at high altitude, some aircraft are equipped with A. Vapor separators. B. Direct injection type carburetors. C. Booster pumps. The correct answer is C. To prevent vapor lock in fuel lines at high altitude, some aircraft are equipped with booster pumps. Vapor lock occurs when the fuel in the lines or carburetor becomes vaporized, leading to a disruption in fuel flow and potentially causing engine performance issues. Booster pumps are designed to provide an additional boost of pressure to the fuel system, helping to prevent vapor lock by ensuring a consistent and adequate fuel flow. These pumps assist in maintaining proper fuel pressure and preventing the formation of vapor bubbles that can disrupt fuel delivery. Vapor separators, on the other hand, are primarily used to separate and remove vapor or air bubbles from the fuel before it enters the engine. While they play a role in fuel system operation, they are not specifically designed to prevent vapor lock in fuel lines at high altitude. Direct injection type carburetors are a type of carburetor used in some aircraft engines, but they are not directly related to preventing vapor lock. Their main purpose is to provide precise fuel metering and atomization for optimal engine performance.